Welcome back. Today, we're going to pull back the curtain on a crucial piece of Kubernetes that does all the magic in the Cloud Controller Manager. Let's get right into it.
So let's start with a question that I swear gets every single one of us at some point. You've built your app, it runs perfectly on your laptop with Minikube or Kind, everything's great. And then you push it to a real cloud provider, and suddenly some things just feel different. They don't work the same way. What is going on? Well, the answer really comes down to the huge difference between running something locally on your own machine versus running it inside a massive, complex cloud environment like AWS, GCP, or Azure. Let's break that down. See, on your laptop, your Kubernetes cluster is this perfect, self-contained little universe. It has everything it needs right there. But the cloud is a totally different beast. For your cluster to really do its job there, it needs a whole new set of, well, superpowers. And what kind of superpowers are we talking about? We're talking about the ability to actually ask the cloud provider, hey, I need a real public-facing load balancer, or can you please provision an actual persistent storage disk, like an EBS volume? It also has to manage the virtual machines that are your nodes and know critical info about them, like which availability zone or region they're sitting in. These are things that they don't even exist in your local setup. So this leads to the big question, right? If Kubernetes wants to be this generic works-anywhere platform, but it needs to do all these very cloud-specific things, who's the middleman? Who takes a generic request from Kubernetes and translates it into a very specific API call for AWS or for Google Cloud?
It's time to introduce the hero of our story. Meet the Cloud Controller Manager, or CCM for short. You know, at its heart, the idea is actually pretty simple. It's a special little program whose one and only job is to talk to a specific cloud provider's API to handle all those cloud-only tasks we just mentioned. It's the specialist that Kubernetes calls when it needs something done in the real world. I love this hotel analogy because it makes it so clear. When you ask for a load balancer service in Kubernetes, it's just like asking the hotel front desk for Wi-Fi. You, the guest, you don't care how it works. The Cloud Controller Manager is like the hotel staff who actually calls the internet provider, AWS or Google, to get that connection set up for you. Same exact idea for asking for storage.
And let me be really clear here, this isn't just some nice-to-have feature, it is absolutely critical. Without a Cloud Controller Manager in your cluster, that load balancer service you created would just sit there, its external IP status stuck on pending forever. It's literally waiting for a translator that just isn't there.
Okay, so we know what it is, but what does the Cloud Controller Manager actually do? Let's break down its 4 main jobs. You see, the CCM isn't just one program. It's really a team of smaller, specialized controllers. There's a node controller that makes sure your Kubernetes nodes have all the right cloud info, like their instance type and zone. There's a route controller for some networking stuff, but honestly, the two you're going to run into the most are the service controller, which is the one that creates those load balancers, and the persistent volume controller, which is what provisions real cloud storage for your apps. Theory is great, but let's see this thing in action. We'll walk through the most common example there is, getting a public IP for your application. So it all starts with you. You've got your YAML file for a Kubernetes service, and in there you have that one magic line, type load balancer. You run your normal kubectl apply command, and then you wait, expecting something to happen. And here's what's happening behind the scenes, step by step. The second you hit enter, the service controller inside the CCM sees that new service pop up. It spots the type load balancer request and immediately springs into action. It goes, authenticates with your cloud provider's API, and says, hey, my user needs a brand new load balancer, please. Then, maybe a minute or two later, the cloud provider finishes its work and hands back a public IP address. The Cloud Controller Manager grabs that IP and writes it right back into your service object in Kubernetes. So when you run kubectl get service, this magical external IP has just appeared out of nowhere. It's not magic, it's the Cloud Controller Manager doing its job perfectly. So this brings up a really important question. Why is Kubernetes designed this way? I mean, why not just build all this specific cloud logic directly into the main Kubernetes code? It all comes down to a really smart core architectural decision. The folks who created Kubernetes wanted the core of the project to be totally generic. It should work exactly the same on a developer's laptop as it does in a giant data center. And to do that, they made the brilliant move to pull all of that cloud-specific code out into its own separate thing. And this gives you this beautiful, clean separation of duties. You've got the standard kube controller manager that handles all the generic logic that has to work everywhere, like making sure you have the right number of pods. And then you have the cloud controller manager, the specialist, which only has the code for one specific cloud and only runs when you're actually on that cloud. This summary really drives the point home. Keeping your pods running, that's a generic job. The kube controller manager does that everywhere. But creating a real load balancer or a real storage disk, on your laptop, you need a special tool like MetaLLB to fake it. In the cloud, that is 100% the job of the cloud controller manager. So look, if you walk away remembering just one thing today, let it be this. The cloud controller manager is the essential translator that lets your generic Kubernetes requests become real, tangible resources in a specific cloud. And there you have it, the secret's out. The magic behind how your services get those public IPs isn't magic at all. Now that you know about this critical translator, what other parts of the cloud seem like magic to you? Let us know what you want to uncover next time.